Now that we've seen what vertex form is all about, let's go ahead and take a look at an example and work a couple sample problems. You can see here in example number 2, we have f of x equals negative 1/2 times x plus 3 squared plus 4. Now, we should recognize this as vertex form when we see it. A couple things to start. Before we even graph this, we've got to understand immediately what this a value tells us. Now, the negative tells us that it's going to open down, and the fact that it's 1/2 tells me it's going to be just a touch wider. And then we can identify the vertex through simply looking at the h value and the k value. And so you remember these are the h's and the k's. Now inside the parentheses we're doing the opposite of what it suggested, so that's going to be a -3 and then a +4. And so you can see just through sketching off here to the side, I have a pretty good sense of what my graph should look like when I'm finished, and what direction and where it's kind of located. So, and you can work your way through this information here. Now, just in case you forgot why the 3 or the -3 is opposite, you can see that I've written it with the vertex form of x minus, and of course you can see how that plays out. Now, first thing we're going to do to graph this is to actually plot the point -3, 4. Our axis of symmetry is going to come through that vertex, which in this case is x equals to -3. And then we're going to want to just t-chart a couple points off to the side. Now, I always make an effort to t-chart some easier x values. And in this case, this example chose to use -1 and a +1. And you can see that the reason they did that is because if they would have chose -2, or if they would have chosen a 0, it would have given them a fractional point. So they just moved on and to points that were going to give them some clean points on a grid line. So once we plot those 2 points, it's just as we did before in standard form. We just find the symmetrical point on the other side of the axis of symmetry, and we simply try to sketch the parabola through those points as best we can. So this is actually a little bit more streamlined than it was in prior standard form. So let's take a look at sample problem number 2. We're asked to graph it, and then we're asked a question about what are the zeros of the quadratic. So I'm going to go ahead and work this for you, and you can take a look at it as I go through this. So the first thing that I'm going to want to do is identify the vertex, and so the vertex is -1 and -2. So I'm going to go -1, -2, and of course my axis of symmetry is going to run straight through that vertex. Next thing I want to do is, and of course if I was asked to identify the axis of symmetry, I would need to write it as the equation of a vertical line. The next thing I'm going to do is actually plot a couple points, and so the easiest x values, it looks to me, would be 0 and 1. And this is where you can use your calculator effectively. If I plug in 0 for x, you can punch all that in your calculator and you'll get actually a value of 0 in this case. So if we go farther and we take 1 as an x value, we plug 1 in as an x value, we're going to get a value of 6. And so then we can plot those 2 points, 0, 0, and 1, 6. And we have 2 points on 1/2 of the quadratic. Now we just need to take the symmetric points. So that's 1 unit away, so it's going to be 1 unit here and 2 units up there. And we're going to do our best to draw that quadratic. And of course we should have known that based off of the 2 there, that it was going to be a little bit steeper and it was going to be opening up. Now it says what are the zeros of this quadratic, and so we want to find the zeros. Well, fortunately for us, we kind of found one through our x y t chart. 0, 0 would be considered one of the zeros. And then, of course, based off its symmetric point, we can see that -2, 0 is also a 0 of this function. So wherever it crosses the x-axis or the x-intercepts, those are going to be the zeros of the function. And so we've graphed the given quadratic. Now, of course, as always, we can use our calculator to help us out with this if we have it available. And we just simply punch in the given information the way it was given to us. And you can see that that looks very much like what we graphed on our notes. Now, if I wanted to double check the zeros, I could use a menu function. And if you go to Analyze Graph, you can do 0. Now this is going to require you to pick a left bound and then a right bound. Now, here's the thing. Notice when I bring this over, it will not give me both of the zeros at the same time. You can get it in one range there, and then of course it moves over to the other one as you get to the other side. But you can see the -2, 0 and the 0, 0. So you can do them one at a time. And of course, if I wanted to do that again, I could actually go from here to there, and that would give them to me both at the same time. So you can see that the calculator can help us find these parts as well. Alright, I'm just going to work through this next one, and you can check your work against mine. Okay, quick look at this. We identified our vertex based off of our h and our k. We could also identify that it's going to open down because of that negative. And I just t-charted a couple extra points. And again, I was a little fortunate here to find my 0 within my t-chart, and then I could find the symmetrical point within that so that I could get my two 0 values. And then I just simply find the symmetrical points and graph the vertex, graph the quadratic, and we're done. So good examples of graphing and vertex form.